Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Last session we have seen about decimal number system, binary number system, hexadecimal number system and octal number system, right? And I have given you some of the numbers which is in your book and I have asked you to convert it to decimal number and to send me. No one has sent me till now. I'm waiting for your replies. You can send me privately in my WhatsApp number or you can send it in our group also. And in page number 17 we have another one question. State whether the following numbers are valid or not. If valid, give reason. This one also you can find out. 786 is an octal number. You can say whether it is yes or no. If it is yes, you should say why is it octal number, and if it is no, you have to say the reason. Okay, 101 is a binary number. Radix of octal number is 7. This one you can just find it. Yesterday's session itself I have taught you clearly what is octal number, what is binary number and what is hexadecimal number. So you already know what is decimal number. So from that you can just answer these worksheets which are in page number 17, right? You just try to answer and send it to me today itself. Okay, next one, today we are going to see about number system conversions. Here we are going to convert the decimal to binary, decimal to octal, hexadecimal to octal. These and all conversions we are going to learn. Okay, first one is decimal to binary. Okay, here we have two methods. First method is we are converting the decimal to binary by repeated division by 2 method. That means here any decimal number divided by 2 will leave you a remainder 0 or 1, right? When you are dividing that 2, it will leave a sequence of zeros and ones. That will be the binary number of that particular decimal number. Okay, suppose if you want to convert a decimal number n to a binary form, you will divide n by 2. Okay, here in this decimal system we will get a quotient and a remainder, right? And that remainder will be 0 or 1 only, and that quotient you will be dividing again and again repeatedly with 2. Okay, so till the quotient becomes 0 or 1, we'll be dividing it repeatedly by 2. Okay, when the quotient is 0 or 1, that is the final remainder value, and that quotient along with the remainder you will be writing it, and that will be the binary value of that decimal number. Okay, I think you would have got a simple idea. I'll just explain it with an example so you will get the clear idea of conversion from decimal to binary. Okay, let's see the example. 65. We are going to convert this decimal number 65 into binary number. Okay. Here in page number 18, you just refer it. I have given you in screen also. See, 65. We are considering 65 as the decimal number and we are going to find out the binary equivalent for this 65, right? So here we are going to divide this 65 by 2. Okay, first time we are dividing 65 by 2 and the value is 32, right? When you are dividing 65, what is the half of 6? 3. And what is the half of 5? It is 2 and balance is 1, right? So it is 32 hyphen 1, right? Same way again 32 we are dividing by 2. What is the half of 3? Half means we are going to divide this 3 by 2. Okay, 2, one time only 2 will come, right? So here 1 and then one balance is there. 3 in 3 we are considering only 2, one balance is there, so that 1 will include with 2, so it is 12. 12 divided by 2 is 6, so it is 16 and no balance, so it is 0 hyphen 0, and 16 if you are dividing by 2 it is 8. So 8 hyphen 0, no balance. Again 8, if you are dividing by 2, it is 4 hyphen 0, no balance. And then again, if you are dividing by 2, 2 hyphen 0, again 2, if you are dividing by 2, it is 1 hyphen 0, right? So here, the last one is the MSB. That one we saw yesterday itself. It is most significant bit. And the top one, first we'll get one reminder, right? That one is LSB, that is least significant bit, right? So here we'll start from here, from this left end, and you will be writing 1 0 0 0 0 0 1, right? So this is the binary value of 65. Okay, here they have given it clearly inside this note also. 65 divided by 2 is 32 and 1 remainder, right? And again 32 divided by 2 is 16 plus 0 remainder. 16 divided by 2 is 8 plus 0 remainder. And again 8 divided by 2 is 4 plus 0 remainder. 4 divided by 2 is 2 plus 0 remainder. And again 2 divided by 2 is 1 plus 0 remainder, right? So here from down we'll start 1 0 and then till top end we'll be writing, and that is the value, binary value equivalent to the decimal value 65. Okay, and we are having another one method also, right? So the second method is sum of powers of 2. That means a decimal number can be converted into a binary number by adding up the power of 2 and then adding the bits as needed to obtain the total value of the number. See this method, that is dividing by 2, is the easy one, right? You just prefer this itself. You just find the binary numbers using this method itself. I'll just teach you this method for your reference alone. When you are converting a decimal value to binary value, you just prefer this dividing method itself. Okay, we'll see the another method also now. You just learn only one method. If you find this first method as the easy one, you just study the first method itself and apply that whenever you are converting a decimal number to binary number, right? Let's see the second method now. It is done by adding up the powers of 2 and then adding bits as needed to obtain the total value of the number. Okay, first you are going to find the largest power of 2, that is the smaller than or equal to 65. Okay, then set the 64's bit to 1 and then subtract 64 from the original number. That is, our number is 65, right? So we are going to subtract 64 from the original question. What is the question? 65, right? From that number. And then uh, 32 is greater than the remaining total. So set 32's bit to 0. And then 16. 16 is greater than the remaining total. So set the 16's bit to 0. 8. 8 is greater than the remaining total. So set the 8's bit to 0. 4, same way, greater than remaining total. So 4's bit to 0. Right? And then 2 is greater than the remaining total, therefore 2's bit is 0. As the remaining value is equal to 1's bit, set it to 1. So 1 minus 1, 0. Right? So here the conversion is done. Here if you see, we are going to see the remaining values there. Right? 65 means we will see the power for 2. So 64. So you will get the remaining 1. Other than that, 32, 16, 8, 4, 2, 1. These are all the even numbers, right? So when you are dividing by 2, the remainder will be 0 only. So those values will get it as 1 0 0 0 0 0 1, right? Here in this step, if you see, conversion steps are given in page number 18. You don't have to learn this. You can just stick on to that type itself. In 18, the page top, you are having one division type, right? That method itself, you can convert the decimal to binary numbers. Okay, here in the second step, if you see, we are just putting the tabular column for each 64, and then what is the next power, or dividing by 2 means 32, 16, and the remainders we are mentioning it in the below columns, below row, and then you are going to get the binary value there. So this is a little hard. You don't have to learn this step. You can just learn this method itself. 65 means 65, and you can divide it for 2. When you are dividing, you'll get 32 and you'll have one balance. This model itself. Okay, you don't have to learn the other one. Don't confuse it with the other one. You can just learn this model itself. So today we have learned to convert the decimal number to binary, right? So you just take some numbers, any number. You can take as per your wish, or you can just take from the book back questions, or in between workshops are there, those worksheets also you can consider, and you can just change it to binary number and you can send it to me. I'll check it. Okay, so first learn the conversion of decimal to binary first. If you are clear with this, we'll tomorrow we'll learn this decimal to octal. That is also easy only. Decimal to octal, decimal to hexadecimal, everything same way only. Here we divided by 2. In decimal to octal means, what is the base value of octal? 8, right? With the 8 we will divide. Decimal to hexadecimal means, what is the base value for hexadecimal? 16, right? So we will divide it with 16. So that way we will be converting the value, decimal value to a binary value, decimal value to octal, decimal to hexadecimal. This is the way to find the, to convert the decimal number system to other number systems. Okay, so today you learned this decimal to binary clearly. Tomorrow we'll see decimal to octal conversion and decimal to hexadecimal conversion, right? Thank you for your valuable time. Stay home, stay safe, take care. Bye.